But is we end up with a square. Isn't that right? Yeah, this is, well, not necessarily a square. Okay, we end up with a rectangle. Okay, and the coordinates here now. So we're interested in. I wonder what this length here. We know how to calculate the area of a rectangle. It's the width times the height. Okay, so I wonder what the length of this is here from C to E. Well, from C to E, well, E is on the vertical, okay, that's parallel to the y-axis, yeah, and it goes through the point x2, y2. So actually, this coordinate here is x2, okay, so that's an x2 coordinate. Okay. E is on the x-axis at x2, because B is on the same line perpendicular, okay, and that's at x position x2. So that means that this distance here, the distance from C to E, okay, it's x2 minus x1. And similarly, the distance from E up to B, this distance here, it's I suppose, well, this distance from here to here is simply equal to y2, isn't that right? Okay. So it's equal to y2, this vertical distance here. So it's equal to this distance here is simply equal to y2. So the area okay, of, let's say, the rectangle, okay, or the square being CDBE, CDBE is simply equal to, it's the width times the height, okay, or it's the length times the length here, yeah, okay, so it's equal to x2 minus x1 times y2, okay. That's that one done. And then finally we have another one, okay, which I'll colour. We have this triangle here. And don't forget, this was a parallel that came through here, parallel, okay, to the x-axis. So this is forming a right angle here. So now we have another triangle, which is this triangle, which is coloured in black. Okay. Once again, we know the base. The base is x2 minus x1. And the height this time, this height here, okay, let me symbolize that, the height here of this particular triangle here, okay, the height is, well, point A is of height y1, okay, and point D is of height y2, so it's y1 without y2, so this is actually, the height here is y1 minus y2, okay. So the area of this triangle, let's say ADB, is equal to half the base. So it's half. The base is x2 minus x1, okay, times the height, which is y1 minus y2. Okay. So really, what we've done is we've calculated the area of this particular structure here, O, A, B, E, because the sum of these three parts covers that particular area here. Okay. Now, we're only interested in the area OAB. Okay. But look at this. You can actually see that this particular area of this triangle in here, okay, that this triangle in here, okay, is not what we require. We don't require this. Let me maybe do that like a hatching, yeah, okay. So we don't require this, okay. Okay, the sum of these three components was the sum of the overall thing, but we're interested in OAB, so we're not interested in this area here. Okay, so this area here of this triangle, okay, so the area, okay, of the triangle OBE is, well, it's half the base. And the base, the width of the base is, well, it's x2, so it's a half of x2 times the height of it, which is y2. So this is the total area of this particular structure. 1, 2, 3, 4. This particular structure here. Okay, this polygon. Okay, the sum of them. But we don't want that. We want the triangle, so we need to take away this particular area here, which is this area here. So let's do that particular calculation. Okay, so I'm going to do it. So what I'm saying is this: is that the area of our triangle. Okay, the area of the triangle at the origin, okay, with a vertex at the origin, okay, is the area. It's the area of triangle OAC plus the area of triangle the area of the square CDBE plus the area of the triangle. So it's the area, okay, uh, ADB minus, okay, the area, okay, of the triangle OBO.